Alright people, so we are now back to solve more roots of a quadratic equation. But the difference this time in this video is that we're going to solve for the roots of a complete quadratic equation. So for example, we have this quadratic equation right here. X squared minus x minus 6 is equal to 0. So you can see we have an x squared term, an x term, and a constant term. And that is what makes it a complete quadratic. Alright, so what is the first step in dealing with a complete quadratic? How do we solve for the roots of a complete quadratic? Well, we need to check if it's factorable. We do a factorability test. So, factorability test, we use the b squared minus 4ac test. So the b squared minus 4ac has to be a perfect square. Alright, so what is a perfect square? Well, a perfect square is a number which is a square of another number. So for example, 1 is 1 squared, 4 is 2 squared, 9 is 3 squared, 16 is 4 squared, and 25 is 5 squared, and so on. Well, you understand. Alright, so where are we gonna get B, A, and C? What are they? So if you still remember the general form of a quadratic equation, let me erase this. It looks like this, remember? So we need to check if this is factorable. So what is our A here? A here is actually just 1. B is -1. And C is -6. Alright. So to check if this is factorable, b squared minus 4ac has to be a perfect square. So let's plug in the values. So b squared, we have minus 1 squared, minus 4, a is 1, and c is -6. So this is equal to 1. So this is minus 4, this is minus 6. Multiply that, you get positive 24. You have 25. And 25 is a perfect square, because the square root of 25 is actually 5. Alright, so let me erase this now. Hope that's okay. Alright, so this is factorable. We just confirmed that. So what do we factor this into? So it's going to look like this. And we have x here and x here because there's no coefficient there, right here. So we have x, just x here and x here. Okay, so what do we fill this up with? Okay, do you still remember how to factor? I hope you do. Well, if you don't, I'm just going to show you again. Okay, so right here, you have -6, right? -6. So we need to think of two numbers a and b, that if we multiply a and b, we get -6. Alright. And a plus b also has to be equal to -1, which is the coefficient of -x at the middle. -1. So think of two numbers that will satisfy this. So I have to think about that. So, are you done? Let's try -3 and 2. Does that work? So -3 times 2, you have -6, and -3 plus 2, you have -1. So that works. So we just plug that here. -3 and +2 plus 2. Alright. So there we go. It's now factored out. Okay, so what is the next step? So we have two factors on the left side equated to a 0. So remember that step? We split the equation into two smaller equations. So on the left side, we have x minus 3. And on the right side, we have x plus 2 equal to 0. So here, we just move the -3 to the other side. It becomes +3. And here, we move the +2 to the other side. It becomes -2. Alright, so there we go. We now have the two roots. Okay, so it's now time to check. Alright, so let me erase this. Let me put a boundary here. So I'm going to put here check. Okay, so let us first test x is equal to 3. Okay, so we're just going to plug that in. So here we have 3 squared minus 3 minus 6 is equal to 0. So here we have 9 minus 3 minus 6 is equal to 0. So we have 9 minus 9 is equal to 0. 0 is equal to 0. So that's good. That's good. And now we're going to check this one. X is equal to minus 2. We do the same thing. We just plug it into x. So minus 2 squared minus minus 2 minus 6 equals 0. So negative 2 squared, that's 4. So minus negative 2, that is equal to just positive 2. And here we have minus 6. We just copy that. Okay, so here 4 plus 2 is 6, minus 6 equal to 0. There we go. So now we have the two roots. We have x is equal to 3 and x equal to negative 2. Okay, so it's time to do another example. So here we have this equation. X multiplied to quantity x minus 8 is equal to 2x x minus 1 plus 9. There we go. Okay, so we have an equation that is not in general form. So we just make that into general form. Here we multiply x to x minus 8. So we get here x squared minus 8x. And here we have 2x squared multiplied to x. So we get 2x squared. And 2x multiplied to negative 1 or minus 1. We get minus 2x. And then here, just copy the 9. But we want 0 to be on one side and all the rest of the terms on the other side. So here we're just going to move these to the right side. Okay, so here we go. I'm just going to put here 0. And then here you have 2x squared. We have an x squared term on the other side, so I'm going to write it here. So that becomes minus x squared on the right side. And here we have minus 2x, and then we have minus 8x on the left side. So I'm going to write it as plus 8x. Then we just copy the 9. All right. Okay. And I don't like 0 being on the left side, so I'm going to move it to the right here. So here I'm going to add 2x squared minus x squared. So that's just x squared. And here we have minus 2x plus 8x. That becomes plus 6x. And we have plus 9. So do you recognize this? This is a perfect square trinomial. So if you don't remember that, remember this. Try to remember this. We have this a plus b quantity squared. That's equal to a squared plus 2ab plus b squared. It perfectly resembles this. So to factor that out, we just follow this formula right here. So this just becomes x plus 3 squared. Or you could also do x plus 3 multiplied by x plus 3. Yes. Okay, so don't really need to split the equation because it's just x plus 3 equal to 0. And our value for x is equal to minus 3. There we go. So you want to check that? We can go right ahead. All right, so we can plug in, since this is our general form of the equation, I'm going to copy that here. So that's x squared plus 6x plus 9 equal to 0. And then we're going to plug in minus 3 for x. So this becomes minus 3 squared plus 6 minus 3 plus 9 equal to 0. And here we have minus 3 squared, that's 9. Here, 6 multiplied by minus 3, that's minus 18. And here we have 9 plus 9. And that's 0 equal to 0. There we go. So this is correct. So you actually have two roots. x minus 3, and x minus 3.